We are Team FHIR Buffer Overflow, and this is Deliverable 2, which includes an architectural diagram and a screen prototype. The presenters will be Pauline Shou and Varun Bell. This is our current Gantt chart. As of this video, D2 is fully completed, and we will be moving on to D3. One of the project requirements is to enable effective modularity for these PH bulk data API. The project or module should be modular enough to be shared with a specific partner or multiple partners. As long as the FHIR data model, the authorization, and the support for the bulk data API commands are in place, consumers should be able to use the bulk data API without much difficulty.
These are the FHIR bulk data API definitions. We could extract all data, whether or not they're associated with patients. These are especially useful for backing up a database, migrating a database, or exporting terminologies from the database. We could also extract all data on all patients. Other than that, we could extract subset of patients using group IDs, which are often helpful for insurance companies. We could extract patient data by date and also by resource.
This is a screen prototype of a situation where we are showing the obesity rates within Texas counties. The first image shows a website snapshot of the current obesity rates. It'll be a county-based map of the index. The second image on the top right is descriptive statistics, and the third image on the bottom is incidence rates calculated by total new patients in obese/total number of patients tested. We will be updating the screen prototype on an iterative basis, and some of the images may be subject to change.
This is the architectural diagram for our project. Our final product will be a needs assessment report visualization. Basically, we want to make it really easy for public health agencies to perform routine analysis on massive data. Ideally, the APIs should be reusable or scalable to other public health agencies as well. We also want to provide user-friendly graphs, figures, and findings to include in the reports. In this diagram, we start on the very left by extracting data from the test servers. These are the public test servers that are hosted on GitHub that we can pull online. After that, we'll run the synthetic data generator to generate some data on these test servers. So on a weekly basis, we'll go through a weekly data curation process. And the curator is basically just a console app that will be invoked via some kind of cron job. The curation process frequency is subject to change, but we think weekly is a good start. We'll call each FHIR bulk API for all the bulk data, reconcile it with the data that we already have, and mark new data for inclusion to be processed and inserted. Once that happens, there should be some sort of RPC to the analytics engine that will crunch the curated FHIR resources and populate the analytics database with the needs assessment model for the given time frame. Some of the data that we'll store in this process are raw FHIR resources, OAuth tokens, OAuth keys, and service directory. Then the client application can call whatever API we wrap around the analytics database to populate the visualization.
We are going to be using JavaScript for the front end and Java Spring for the back end, including Python and SQL for the database.
Our main concerns are about the HDAP infrastructure. We're not sure if we should be implementing all our components on a monolithic platform, and we're also not very sure how to store our data and where. Since we have multiple test servers, it could be possible that we have data conflicts on patient resources. We also need to figure out how to reconcile data conflicts.
Our next steps are to spin instances of the test servers, pull and load data from the 3 suggested test servers, and use them to generate synthetic data. We want to analyze how we derive the final data and metrics from the bulk data API. We have to figure out how to implement auth verification on the curator, understand HDAP infrastructure and how our code can run on it, figure out the Jenkins pipeline that's required by Georgia Tech, and add test cases for all of our development scenarios.